Okay, as the title promises, we have a ridiculously oversized and impractical storage system, which, yes, is fairly true when you look at the size and how complicated the setup is, and it only stores 16 minecarts with chests, so the equivalent of 8 double chests, which you can fit in a much smaller area with no fuss. But this is, as complicated as this might seem and oversized, what we are actually featuring in this episode is this. Okay, what we are looking at here is essentially 16 of those units put together with the necessary modifications and expansions. So we can store 256 minecart chests, the equivalent of 128 double chests, and each of those are individually addressed and can all be delivered to a central location. So here we have our delivery location where we will be accessing all of our content. There is where the carts will arrive. This is our control panel. We have 8-bit addressing, so we have 8 individual bits that we can set to choose an address of what we would like delivered to us. We have the call button over there, and over here we have a chest which simply holds an inventory book. Okay, let's just start with a few examples. So we'll go over here, we'll grab our inventory book. Let's open it up. And we see I've got 8 different items put in various locations. I just kind of picked locations at random to put them into. And so what we will do is let's start with stone. And we see that its 8-bit address is 01001010. Now that will just correspond to our control panel here. A 0 is an off, a 1 is an on, and that is represented by the lights. So let's now make that match, and we will call up the stone. So we have 0, 1, 0, 0, 1, 0, 1, 0. Let's just double check that we got that correct. 0, 1, 0, 0, 1, 0, 1, 0. Great, now we will hit the call button. And now this is one of the reasons why this is very impractical due to the size of this. It does take about 15 seconds for the cart to be delivered. It does return slightly faster because of no delays in redstone, but that takes about 14 seconds. And there we go, this is our stone minecart. We will return it with this button. Now, because of that 14-second return delay, we have to wait before we make any changes to this after returning one, because you don't want to end up sending that cart back to a different address because you were changing the address at the time it was sending. Now we saw it did arrive, so let's now pull up a different one. Let's get some diamond blocks. Everybody loves diamond blocks. So that's just 11001100. So, oops. 11001100. Now we hit the call button, and our diamond block should be on the way. You did notice there's a bit of lag there. There's an awful lot of stuff going on at once here. A lot of redstone changes being made. So you will notice a slight little bit of lag as it's taking care of that. And so here we have our diamond blocks. And now let's send those on their way. Okay, we've had a few examples of this in action, so now let's take just a little bit of a look at how this works. I have this reset all to zeros, and we'll go through a bit of the functionality. Let's start by tracing the rail back, because that's the first thing it does is these rails here will switch depending on the address that is set. If we look here, this one here is set by the light blue, which is the final bit here. I say final because in binary you work kind of from right to left. So that there essentially selects between the lower 2 levels and the upper 2 levels. Now, if you're not familiar with binary, let me give you a quick explanation. From right to left, this bit here will represent a 1 or a 0. And then it doubles as you go along, so the yellow represents 2 or 0, the pink 4 or 0, the green is 8 or 0, 16, 32, 64, 128. And so what happens is that you add them all up. If these are all on, you would add that all together and you would get 255. Now you might say I said 256 before. That's because the first position is by 0. Everything off here represents a value of 0. Everything on represents 255. Knowing the numbers isn't really important unless you can read binary and want to simplify your inventory by just giving it a actual hexadecimal number rather than binary. But anyways, let's follow this rail back. So with this being in the off position, we are switched into the lower half of the machine, which we will follow along. And this next level, which is the magenta here, then splits between, it basically splits in half every time. So we were split down to the lower two sections out of 4. This is now splitting us to the bottom section out of the 2. Each section has 64, so we split into the bottom 128. We were splitting into the bottom 64. Now another thing I want to point out while we're at this point is that some of you might say that some of my rails are really inefficient, because if you notice, for example, this cart here could travel almost straight across, just up just a little and straight there, and would be there rather quickly. The reason I have run it the way I have is because every single cart has exactly the same distance to travel now. Now I might be off by 1 or 2 rails in this vertical transition section, but in horizontal they're all identical distances, and they should be within 1 or 2 at the most, which means that every cart that you call should be there in the same amount of time so that the machine is consistent. Regardless of how fast I made these middle ones, the far ones would be slow, and I would rather have them all be the same speed so that you know the time of the machine rather than having to guess at it. But anyways, let's continue down following the track. We're following down here. We now split this bottom section into half with this section, and we're going to the right. So we now split the 64 into 32. Now this switch splits the 32 into 16. We'll follow it over. 16 is split into 8, down into 4, into 2, and then into 1. And this is our 0 position, the bottom right of the machine when you're looking at it from the control panel location. Okay, so now we have correctly set up the path, but we need to send a signal to the cart to get it up to our location over there where we are at. Now, if we just powered every single cart, this one would make it through, assuming it didn't collide with any other ones. But, for example, when these 2 carts are powered at the same time, well, for one, they would collide right away. But assuming that this one made it through, this one would then, the second position would come around, and it would end up in the first position. And then when we sent the first position cart back, it would end up getting stuck here rather than going to its proper position. So what we need to do is find a way to send the signal to only the correct cart to have it sent. Now the send signal comes across these power wires on the back, running along the stone. We've got those on all 4 levels. And then what you see here, all of these color-coded sections, this is an 8-bit decoder. When we send the signal, depending on the combination of different bits that we have turned on, it will only allow power through the correct one. So right now, when we have all the 8 bits turned off, these pistons in the first position, all 8 of them, color-coded, are raised. So they are in the raised position when the bits are turned off. And so when we power this, we will be able to send a power signal through all of those pistons to the cart, and it will turn on that powered rail. Now, because of the way this works, there are a whole multitude of combinations. If we were to switch this bit, every single blue wool piston here would switch position. These ones that are normally powered would drop, and these ones that are normally unpowered would raise, and it would make for a different combination. In this case, this lane here would then be able to transmit power across the whole length. And that's all switches at the same time as rail switches do. So if we were to switch the blue, we see all these rails would switch to the left instead of the right on this line, and all the way up. They would all switch to the left rather than the right. And these blue pistons would all switch positions. The ones that are up would go down, the ones that are down would go up. And that would send a power signal through here, and this would have the correct path all the way up. And that is just repeated throughout all the different levels. Each of these colors, each bit, has a different, is controlled individually and does the same thing. We have the blue, which matches with this line, the yellow matches with this line of switches, and so on and so forth. So to show you another example, we'll do the easy one. That was the first position, the bottom right of the machine, when everything is turned off, equals to 0. So now if we turn all of these on, we will equal to 256. And we will go up here to the top left. Sorry, I said 256. It equals to 255. But that adds up to the 256th position when you count 0 as the first position. So now we see that these pistons here are all raised in this position. And if we follow these rail switches along, they've all been switched. And we will try and follow it all the way along, and we can see that it will go down into the control panel. And then now we can also see, if we go down back to the first position where we were looking, because it's the complete opposite, this first position, now they're all lowered. So it is a fairly simple concept. We're just transmitting a power signal along to here. The ones that have to be normally raised have this torch pattern. If we find one, it should be back here, that would be normally lowered. It has this torch pattern. And so when the signal transmits along, it'll just invert to that first set of torches that will transmit up through, and that's how we are doing that. Now finally, let's take a little bit of a look at the wiring. Just so you know, I did have this built in using regular redstone wiring. I did use it in Creative. It was on a private server, but it was in 1.6.4. So we didn't have, for example, these set block commands and such to do that kind of wireless redstone. I did have it all wired up. It was very ugly. It was hard to see. Wiring was everywhere. It was a mess. So I cleaned it up. I color-coded everything so you could have a good look at it. And I set it all up in 1.7.2 using wireless redstone, as you can see down there. So let's start with a simple one. This is our call button here. All we have is 4 different command blocks with a set block command to the correct coordinate, setting a redstone block. So that is just on those wires I showed you around back. You can kind of see them, the stone blocks that go along. It just creates a redstone block to power up the redstone wiring there. And it does power every single location at once. But like we saw, the 8-bit decoder only allows power through to the correct location. And now after a 8-tick delay here, we've got the same coordinates again, but it is setting it to air rather than to a redstone block, so it takes power away. So I did have it set to 4 ticks, which is fine, but I found it created more lag, so that's the reason we went with the 8-tick delay. Now, we will take a look at our control panel here. What I've done here is created just a little T flip-flop. It's a fairly nice compact mechanism that I came up with for this. I'm not going to claim that no one else has made this before, but I didn't get this design from anyone else. They came up with it independently. Now there's one caveat to it, which I stumbled upon is that it only works this compact if you make it facing either east or west. To go north or south, you would have to move this piston one block further and put a repeater or redstone dust. But if you use dust, it's not tileable. So you need a repeater there, extend it one more. This would have to come back with one more repeater. But all that happens here is we have a 1 tick delay. So this will come up and cut it off after that 1 tick. So this will push down. Because it's a 1 tick signal, it will leave the block in a lowered position. That torch will power through the block to this repeater, which powers this block, and it has the redstone lamp in behind. Now the wireless portion of this is down below here, where we have, I will activate this so you can see what we're looking at. Was this active? That block got left in that position, powering that. Now down below, we just have a redstone clock here, powering each of these sets. I've color-coded everything. And all there is a test for block with the location that wall is currently in, and just the block it's testing for, which is wool. And you see here, output successfully found a block at 1180.51. So that is that block in a lowered position there. The comparator gives a true output, which powers through this block and powers these here. And again, we've got set blocks. These first 4 are setting redstone blocks that power the wiring that switches the rails. And these 4 are setting redstone blocks that power the 8-bit decoder section. So let's just go take a look at those real quick. So if we wind our way through, this is a block that was created to power the rail switches. It transmits all the way along, turning off these torches, which will turn these rails the opposite direction. Same for all 4 layers. And back here in the center of our 8-bit decoder, that blue wool block that had the dust on it has been changed to redstone block, which creates power, and that's transmitted all the way along the 8-bit decoders. Now we will come back here and we will invert this and see what happens when we undo it. So now that block is no longer there. It is no longer detecting. The block at 1180.51 is tile.air.name, so it's not wool like it's looking for. So we get no output, which means that this torch is on, which powers this upper section. So this here is simply for the rail switches, setting those redstone blocks to air. And these here are for the, these are for the 8-bit decoder, turning those redstone blocks back to blue wool. So if we come back over here, this is where the redstone block was, and this here is where that redstone block was, but it is now blue wool. Okay, that's it for the wiring. All the other sections are essentially the same, only slight difference being where once we get into these ones that are splitting vertically, rather than setting a redstone block on top of the wiring like we did there, we are just exchanging these blocks for redstone blocks, but it's essentially the same. Now, like I said, I did originally have this all wired up the old school way. There was no command blocks, no wireless redstone. It was all wired with traces. I had stone block traces going everywhere with redstone wire on top. It was an awful mess, but it was completely functional. It had a bit more delay sometimes, just because of the ways I had to wire it. But if you ever did feel like you wanted to build this in a survival world because you're absolutely mental, you can go ahead and build it all. You can do it without any command blocks. It's completely possible in vanilla survival Minecraft. But now, speaking of something you build in survival world, this little guy over here now looks a heck of a lot more reasonable than it did at the start. This might actually be a somewhat reasonable system that you might decide to use. If you wanted to store a small amount of, let's say, more valuable items perhaps, that you don't have large quantities of, that you want something a little special for, so maybe this could be your diamond and gold storage, or armor and swords, or something like that, this system is significantly quicker. I never prettied up the wiring or brought it really to a central location, so this here is just the addressing system. And these are all on, so it's for position number 16 over there. If we hit the call button, you can see that it is fairly quick, much quicker than the 15 seconds that takes on that one. So you can send that back, and you can, after waiting for a few seconds, you can make your changes here, and let's call that cart. It'll be cart number 4, and that comes over. So there you go. I hope I've maybe sparked a little bit of interest or got some creative juices flowing. Again, I did not do this for any practical purpose, but I really enjoyed the concept. I had a whole lot of fun building this, and I hope that you enjoyed seeing it.